Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Count the number of consistent strings, Leetcode 1684. In this problem, we are given a string called allowed, consisting of distinct characters and an array of strings words. A string is said to be consistent if all the characters in the string appear in the string allowed. Then we should return the number of consistent strings in the array words. Then in example 1, allowed string is AB and following words are given. Then word AD is not consistent as it has an extra character D which is not present in the allowed string. Similarly, BD is not consistent because it also contains an extra character D. Then string AAAB is consistent because it has characters A and B and both of them are present in the allowed string. Then we see string BAA is also consistent because it also has only two characters A and B which are present in the allowed string. Finally, the last string is not consistent as well as it also has extra characters other than the characters present in the allowed string. So we only have two consistent string, so we will return 2 as an answer. One of the naive ways to solve this problem will be to go through each word in the words array and then go through each character in a word. So it will be like a nested loop. And then check if it matches each character in the allowed string by looping on the allowed string as well. So it will be like 3 nested loops. And anytime the characters don't match with the characters in the allowed string, we mark the string as inconsistent. Otherwise, we will count the string as consistent. And finally, we return number of consistent strings. Now, in terms of time complexity, it will be O of n into m into k, where n is the number of letters in the allowed string and m is number of words and k is average length of each word. But if you look at the constraints, n can be at maximum equal to 26. So in a way, the time complexity will be O of m into k. And now the question is, how can we do better? And the answer is, we are looking up the characters from word again and again in the allowed string. So why not just build an hash set on it to reduce our time complexity? So instead of O of n lookup, it will be O of 1. But in this problem, n is just 26, so the improvement will be there. But given the constraint, it will not change our complexity asymptotically. Now let's look at the hash set based approach. So instead of now looping onto the allowed string, we can just create a set and add all the characters from allowed string to it. And then the logic stays the same. Now instead of looping on the letters of allowed string, we will check if each character of word W exists in the allowed set. If it does, then this is a consistent string, so we will count it as 1. But if at any point it contains a character which is not present in the allowed set, that means this is an inconsistent string. So now let's see this in action. So in example 1, we can create our set with A and B. And now we will go through each word through this loop. And then we go through each character of each word using this loop. So we will see that first word is AD and first character is A. And we will see that A is present in the allowed set. So we will go to the next character. Then we see the character D and we see that D is not present in the allowed set. So that means this word is not consistent. So we will not count it. Then we go to BD. Again, we see B is present in the allowed set, but D is not. So we will also not count this string as consistent. Then we will go through each character of AAAB and we see that all its characters were present in the allowed set. So that means this is a consistent string and we will count our first consistent string and so on. And now let's jump into the code part to see the actual implementation. So let's first create the hash set of allowed characters. Now let's add each character from allowed string to allowed set. So now we want to determine how many words are consistent. So let's assume that all the words are consistent initially and that will be equal to words.length. We will see the beauty of why I chose count equal to words.length instead of 0 in few seconds. So now we will just loop through each word in the words array and then we will loop through each character in the each word. And we want to break out of the loop as soon as we find out this word is not consistent. So we check if the character is not in the allowed set, that means this word is not consistent. So we will decrement our count by 1 and break out of the loop so that we can process the next word. Note that if I would have taken count equal to 0, then I would have to use additional flag or variable like is consistent. And initially we will set is consistent equal to true. And when we are breaking out of the loop, we will set is consistent to false. And then after the inner loop, I would have to check if is consistent is true or false. And if it was true, then I would have increment our count by 1. But because we set count equal to words.length, now the two conditions are kind of merged. So whenever we see the character is not present in the allowed set, not only we just break out of the loop, we also decrement our count by 1. So we merged the two if conditions and got rid of extra boolean flags like is consistent, making our code cleaner and more readable. And finally, when we are done with all the words, we will have right count and we will return that. So now let's run this code. Let's submit this code. In terms of time complexity, it will be O of n plus m into k, where n is number of elements in the allowed string and m is number of words, k is the average length of the word. Because it takes O of n time to build this hash set, and then we go through the nested loop for each word, and that takes O of m into k. But if you remember the problem's constraint, n is equal to 26. And because of this, the time complexity is O of m into, which is very close to naive approach. In terms of space complexity also, it will be O of n, because we are storing the characters from allowed string in the allowed set. But again, n is 26, so it will be O of 1 itself. And here we were using 26 characters, but do we really need to use so much space? And the answer is no. We can store all of this information in a bit mask with a 32-bit integer. So let's learn about bit mask for that. Since the allowed string only has 26 characters and most programming languages have 32-bit integers, we can use 26 bits for each character to check if this character exists or not, similar to what we did in Hashset with 6 bits to spare. So let's take a 32-bit integer and draw the bit positions. And let's say we assign these positions to different letters in the alphabets. 0th bit corresponds to A, the 2nd bit corresponds to B, the 3rd bit corresponds to C, and so on. So we have sort of a mapping now, a bit for every character. What we can do is we can take the characters from allowed string and build the bit mask for that. For example, in example 1, we had string AB. So that means the bit mask can be 1, 1 because both A and B are present. So A is assigned 0th position and B is assigned 1st position. So our bit mask becomes 1, 1 or an integer 3. But how do we map these characters to bit position? For example, A to 0 or B to 1 and so on. And the answer is we can actually use ASCII values for that. And we don't have to know the ASCII values as well. For example, in Java, we can do ch minus value A or character minus character A. By the way, ASCII value of A is 97. So we can also do ch minus 97, but up to you. So when we do A minus A, we will get 0. When we do character B minus A, we will get 1. When we do character C minus A, we will get 2 and so on. So once we have the bit position, how can we build this mask? We can left shift 1 by character position or character index, that is ch minus A. For example, for A, ch minus A is 0. So we do 1 left shift 0 and that will give us 0, 0, 0, 1. Similarly, for B, we will left shift it only once. So we will get 0, 0, 1, 0. Similarly, for C, it will be 2 times. So it will be 0, 1, 0, 0. So this is how we will get a set bit at characters position. So for example, for A, it was 0. So we will get 0th bit set. For B, we got first bit set. For C, we got second bit set. And then in example 1, for example, we can see A and B are together. So how can we get this kind of a pattern? And the answer is we can apply bitwise or between bit masks of individual characters. So when we do bitwise or between bit mask of A and B, we will get 0, 0, 1, 1, for example. So this is how we will get the bit mask. And once we have the bit mask, we can actually use it to look up the characters from words, similar to how we use the hash set. Let's take example 1 again. First word is AD and in it, first character is A. We generate the bit mask for A. So we will do 1 left shift ch minus A, that is 0. So we will get 0, 0, 0, 1. And now we see that these two bits are set. So that means we can use an AND operator and we will get 1 as an output. And we use bitwise AND because bitwise AND outputs 1 when all the input to it are 1. And because we got 1, that means A is present in the allowed bit mask. Then we see D. So D minus A is 3. So we will do 1 left shift 3. So that will give us 1, 0, 0, 0. And now when we do bitwise AND between 0, 0, 1, 1 and 1, 0, 0, 0, that will give us 0. And that means D is not present in the allowed bit mask and in turn in the allowed string. So that means this is an inconsistent word. And similarly, we will do it for the other words. So now let's jump into the code part. So first thing we will do is instead of building allowed set, now we will build allowed mask. So it will be an integer and its value will be equal to 0 initially. So now we will just go through the characters in the allowed string and create the bit mask from them by taking bitwise or with characters bit mask, that is 1 left shift ch minus A. And that's how we will build our allowed mask. Now we can take the counts as is and again start looping on the words and then in turn go through each character in the word. And now instead of checking that allowed set contains the characters or not, we have to do the same thing with the allowed mask. So first, let's calculate characters bit mask, and it will be 1 left shift ch minus a, because now we are just taking one character. We don't have to apply bitwise or anything. And now if bitwise and between allowed mask and character mask comes as 0, that means character does not exist in the allowed mask and this is an inconsistent word. Then we will decrement our count, and finally, once we are done with all the words and characters, we will return count. Let's run this code. Cool. Let's submit this code. Awesome. This looks faster. In terms of time complexity, it is O of n plus m into k, where n is the length of the allowed string, m is the number of words, and k is the average length of the word in the words array. And it takes O of n because initially we build this allowed mask and that takes O of n, but n is equal to 26. So that is like a constant. Then we loop over the words array and then we loop through all the characters in the word. So that takes O of m into k. So the overall time complexity is O of m into k. And in terms of space complexity, it will be O of 1, because we are just using this integer to store all the information about the allowed string, and that is amazing. So I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. If you have any questions or suggestions, please write them in the comment box. Thank you for watching. Have a nice time.